So good morning, good afternoon, everybody. So yes, I'm Alex Nichol. I'm part of the product management team. So I'm a technical marketing engineer. My focus is on the software, specifically the routing software, both inside the DC, but also outside the DC. So what I'm going to talk about today is, like, I think one of the questions was some of the feature sets we support, kind of our strategy of what we are developing, what a thought process, and why we're developing those particular features outside the DC. So I'm going to talk a little bit about our routing stack outside the DC, MPLS functionality and such like. So just kind of reiterate what we've kind of covered in the previous sessions. Sham kind of discussed the whole idea of with a cloud grade routing. The whole point here with cloud grade routing is we're trying to move away from a scale up approach, so a centralized approach, to a more scaled out design, right? So scaled out means we can provide more elastic capacity. We can scale better because we're now distributing the state. And you end up with a more evolutional architecture, because now you can bring in new hardware, new feature sets as the merchant silicon evolves. So kind of trying to move away from the rip and replace model, right? And you heard Hugh talking a lot about, in terms of building that architecture, but building it using merchant silicon, because we can then make use of the evolutions of and the new generations of silicon, which is going on an almost 18-month basis, where you're going to look to reduce your cost per bit inside the architecture. So in this session, what I'm going to look at really is just kind of focus on the software stack that sits on inside the architecture. Right? It's going to sit on the merchant silicon and sit in within that sort of cloud grade routing scaled out design. Right? And talk about not just the feature set itself, but our thought process of why we're developing certain features. With the whole point being is that from our perspective, and I think Hugh alluded to this, things are getting very complicated. There's lots of features to support. That doesn't really help OpEx costs. So we're looking to simplify the whole routing stack, simplify it by reducing the amount of protocols used, but still deliver the same amount of services, and also simplify the transport layer as well. Right? So that's kind of our key goal here. Once we can do that, then it makes automation a lot easier. And that's something that we'll talk about in the following session with Rich and Carl. So if I look at this kind of a network edge, right? If you look at a network edge, you're typically going to be deploying maybe one, if not two or three different types of services, right? You might be wanting to deploy an E-line service, or point-to-point E-line service. You might want to be also deploying an E-LAN service, point-to-multipoint. Might at the same time require some layer 3 VPN service, right? And if you are doing layer 3 VPNs, you could also be requiring some sort of multicast VPNs as well, right? The point being is, if you kind of look at this, traditionally we do this, if you look at E-line, for example, there's multiple different ways of doing this, right? You could have an LDB signal pseudo-wire, you could have LV signals with BGP auto discovery, you could then have BGP discovery with BGP signal to do your pseudo-wire, and it's similar from E-line, right? And again, you get then, if you want to do layer 3 VPNs, a completely different BGP address family. And then multicast itself, or multicast VPNs, as much as it builds on IPVPN technology, again, it's additional address family. There's all the different transport options you got. The kind of point I'm trying to make is, yes, we can deliver all these services today with the existing services, but all these different service types have all been developed in isolation of each other, right? And it's allowed them to get very complicated with multiple different implementations, right? So you're going to need different skill sets. If you go from one vendor's implementation to the next, it might not interrupt automatically. So it's getting very, very complicated. So our goal here is, as much as we still have to support these brownfield services, we want to kind of simplify it. And we're looking to simplify that by really driving our software stack around EVPN. So looking at EVPN as a single control plane to deliver all these services, right? So deliver like-for-like services with E-LAN, so EVPN, PPWS. If you want to do some sort of E-line or E-LAN service, should say, I can do layer 2 VPNs. And probably not familiar to everybody, but I can also do layer 3 VPNs with EVPN as well, right? And then there's also up and coming drafts and standards that allows us also to deliver multicast. Now, the point being here is I can deliver all these services, single control plane, so therefore a single implementation, consistent implementation, makes automation a lot easier, but I can also leverage some of the fundamentals that comes with EVPN, right? So across all these services, I can now deliver a standards-based multi-homing approach, right? Whether that be multi-homing using elective EVPN, or single active. I can do that with VPWS and layer 2 VPNs, right? So the kind of point here is not only are we simplifying things, but we're also adding benefit.
Hey, this is Vince Julie. I had a question here.
Yes.
With one of the most common protocols I deal with on a daily basis is VPLS, and it's almost always LDP based.
Mm-hmm.
There's a little bit of BGP AD in there as well. But how do you guys envision, migrating from that over to EVPN? Do you have support for EVPN seamless VPLS integration, or what's kind of the migration path from the old stuff left in the network to the new?
Yeah, and that's a very good point, right? Is because there is going to be a transition period. This is never going to be done as a big bang, right? There's a need for brownfield to slowly incrementally integrate. So yes, there's going to need, and I'll talk a little bit about gateways. So there's a plethora of gateways to do all this interacting between different EVPN domains. So from layer 3 IPVPNs into IPVPN into type 5s. Similarly, there's also a draft for VPLS, not something we support today, but it's something we're looking to support going forward, because this is going to be required, right? It's going to be required if you're going to migrate, if you want to migrate from one service to the other, right? So we see a lot of that where customers certainly see the benefits of EVPN. It's all about how easy it is to get to EVPN without throwing away what they currently have, right? So gateways do become a critical ask in this whole model. Yeah, so if you get kind of digging a little bit deeper here, right? I mean, as I say, we support all these services, the traditional services, but at the same time, as much as we support them, we'll get like-for-like services now with EVPN. But we get like-for-like services, but with benefit with them, right? Not just the benefit in terms of a single control plane, but also benefits in terms of the operational model and the implementation, right? I mean, for example, if I take a point-to-point, well, the LDP signals, whatever, right? There's no standard approach to doing dual homing there, right? You end up with each individual vendor's implementation. If I take a similar service with EVPN VPWS, I've got that EVPN control plane. I can do the auto discovery with the type 1s, but I can also now leverage a standard model for multi-homing into that E-line service, right? Whether it be all active support or a single active support as well, right? Which is an active standby type of model. Same holds true when if they look at a ELAN service, right? VPLS, as we talked about there, LDP, could be BGP signaled. One of the big drawbacks could be seen with VPLS is it's all data plane learning. Again, no standard model for doing multi-homing. You can do all that model, layer 2 VPNs, do that with EVPN, same control plane. The difference now is instead of using a type 1 route, I'm using a type 2 route, do the MAC advertisement. So I'm doing the MAC learning in the control plane now rather than data plane. And again, I can start leveraging all the multi-homing models that I get with EVPN, right? So you can see here, there's a lot of overlap between the different services rather than each service being completely separate for each other, right? Which again, simplifies the amount of skills you require to do the operations. It also means a more consistent implementation across the services. And you'll see that when you start doing automation, right? It means that delivering the automation becomes a lot more simpler because each service is very much consistent with the previous service. Same thing holds true with layer 3. We look at IPVPNs, different address family, unique address family in that fact. But the point being with IPVPNs is that it's only a layer 3 technology, obviously, right? But with EVPN, I can actually start doing layer 2 and layer 3 EVPNs together on the same logical interface. And I can actually even seamlessly combine them, right? So I can have a layer 2 EVPN, put an IRB on it, and have it advertise type 5 routes. So therefore some sort of centralized routing model, and I can then run a layer 3 VPN from that PE node outwards, right? And again, I can do all that on the same control plane as I was running with all my layer 2 services. Right. So we can see there's an obvious benefit of how moving to EVPN really simplifies and provides a more consistent model to delivering all these different services. And multicast holds true as well, right? So next generation MVPN, again, builds on IPVPN, which is a good thing. A lot of overlap in terms of skills and knowledge there. But there's now drafts now doing EVPN multicast support as well, right? Again, building on the whole control plane, building on the multi-homing models. You get multi-homing support again, all active, active standby for sources and receivers. The only additional support you're now adding with the EVPN multicast is additional route types. So type 6 for the signaling of joins, 7 and 8 for syncing if you're doing any multi-homing. So the kind of point here I'm making is that with EVPN, I've got a single control plane and I can deliver all these services, all on a single logical interface. Same skill set in comparison to all the different services we're actually running today, right? It's very complicated. EVPN strips all that down while delivering the same services with a lot additional benefit to them. Now, that complexity we try to strip out doesn't just say the service layer. It also exists, and I'm sure we're all aware, it also exists at the transport layer as well, right? So if you look at the transport layer, it's getting very complicated, or it is very complicated, right? We've got a dedicated protocol for label distribution. The IGP and LDP are ships at night, so you need to do some level of sync to make sure you don't have any black holing during reconvergence. If I want to do any level of traffic engineering, and we're looking at deploying rather than LDP, we're looking at something like RSVP-TE. Right? RSVP-TE delivers the traffic engineering required, but it's not the greatest scalable solution because the control plane and the data plane for the TE, not a lot of state, is sitting in every node or every hop in the path, right? And I would really use TE if I wanted any FR type functionality, right? So the point being here, again, delivers the functionality, but it delivers it across multiple protocols, multiple levels of complexity. If you kind of look at that, and what we can now deliver and what we do deliver now with SR. So SR now, we can actually combine all that functionality into a single protocol. So with SR, what I'm now doing is, I'm now doing the label distribution within the IGP. So in our case, we support ISS SR. We also support BGP-LU to do the label advertisement. So I've now got a single protocol for advertising the prefix and the labels distribution. I can now do traffic engineering. I can do traffic engineering where they're sitting just at the head end. There's no knowledge of any traffic engineering within any node in the path, hop to hop, right? So therefore I reduce the state. And something that's kind of sometimes lost in the whole SR conversation is SR does add value, just even as a non-TE solution, right? Because for the simple fact, if you deploy SR, you get rid of LDP and you can run it, the whole label distribution and the IGP within a single protocol, right? So it simplifies. But at the same time, it gives us traffic engineering, gives us fast reroute, right? TLFA. And we can do that using either a controller model or a controllerless model.
Hey, Alex, can I stop you and ask a quick question? This is
Yes,
Kevin Myers. So, since we're talking about segment routing, which is great, I agree with you completely on simplification of the MPLS control plane. Where are you guys at with SRv6 as compared to SR-MPLS on that journey?
So as of now, when I talk about SR, this is all, as you probably pointed out, is MPLS SR. SRv6 is something we're thinking about, but it's not something on the immediate roadmap at this point in time.
Got it. Okay, thank you.
And again, we build things very much based on customer feedback, and this is all based on customer deployments and customer asks.
Are you doing SR ISIS or SR OSPF or both?
Just in this case, ISIS SR, no SPF.
While we're talking about protocols, do you have support for the full suite of SR? So can you do binding SIDs and SBFD inside of the LSPs and all of those?
Yeah, so we do
not common
SIDs,
things.
So we do binding SIDs, node SIDs, adjacency SIDs, static adjacency SIDs. Yeah, so.
Okay, thank you.
Yeah, so just kind of dig a little bit further in terms of when we talk about SR and SRTE. As I say at this point, it's SR MPLS. Again, our model is very flexible in our outlook and how that can be deployed. So we have kind of, I would say, kind of falls either in one of three buckets. So we have like a static model, if you want to think about it, where you can provision and define the SRT pass either on box or off box by the CLI or via our API. So here what you're doing is going to provision your static pass. You put a color on your SRT path, and then you have the capability to then, via route map, color any BGP route. And then based on the color and the next top of the route, it then resolves over a particular path, right? With the capability to develop and deploy backup paths, different candidate paths based on whether they're available or not, right? If you want to go down the external controller model, where there's more, the paths are now calculated dynamically. Again, we support that type of model, where here you're talking to an external controller. Controller is collecting the topology information via some sort of VPLS neighbor with one of the nodes in the network. The controller then calculates the paths, and the paths can then be programmed onto the head end. And the programming of that at the head end, again, could be APIs, or API that drive the CLI. We also have customers who actually built their own in-house controllers, and what they're actually doing with their in-house controllers is they've actually deployed an agent on the boxes or boxes themselves using your SDK, and the controller then talks to the agent on the SDK via the SDK to then program the path. Or optionally, there's also BGP SRT as well to push the paths. And then a sort of the middle ground between those two approaches, we also have what I would term as a controllerless model using Flex Algo. So here you're now doing dynamic path calculations, but you're doing it on box, and you're doing it on box based on TLV extensions within the IGP. Right. Well, the idea being now that the nodes themselves will advertise their membership of a particular topology, which is in terms of Flex Algo, where each Flex Algo is defined based on a particular topology, and the topology will be defined based on a metric, delay, calculate based on the delay, calculate it on the shortest metric, calculate it using a particular admin group, so we exclude particular admin groups. And again, once you then define your different paths through your network, you can then color that particular Flex Algo, and using the same model as previously, you can then color your BGP routes, and your BGP routes can then be resolved over the different paths based on their colors that have been added to them, right? So the kind of point in where we're seeing the uptake of Flex Algo is really where customers want some sort of traffic engineering, but they don't want to actually use an external controller. So with the Flex Algo approach, it gives you the dynamic constraint-based forwarding, but you don't need the external controller to actually do the calculation of the paths.
This is Nick. I got a question while we're on this topic. I want to go back to the external controller piece. How does, so you've got API or BGP SRTE. Is there any other, is PCEP supported? Is there any other connectivity model that you're using? And do you have a controller? Do you recommend a controller? What's the...
Okay, let me take that. So the first question is, so what I've listed here is what we currently support. PCEP is something that's on the roadmap. So that's something we're kind of developing as we go forward. We don't have our own controller. We don't, at this point in time, there's not an intent to have our own controller. So again, the thought process here is the likelihood of, so when we are dropping into these accounts, if it's not in-house built, the controller, then the likelihood that the controller is already in the customer site. So we work to actually integrate ourselves with that third-party controller. So again, we're kind of open in terms of integrating with any third-party controller. It's all about what protocols they want us to support to do the pushing and pulling of the policy.
Okay. I mean, it seems like there's not a whole lot of controller options out there. There's, less than 5, and one of them's open source, and I don't even know if it's under development anymore. So I think that I'd be surprised if you hadn't had some PCEP requests, just because that seems to be what the majority of the ones that already exist would be in there.
No, I don't disagree with you, right? But as I say, where we have seen this initially, when we talk about controller, is either one of two models. The controller is being built in-house by a software developer, right? So that's where the SDK piece comes in when they put an agent on the box itself.
I missed that part of your comment. Being built in-house, I heard that totally differently, and now it makes more sense to me.
Okay, sorry, not in-house by us, but in-house by the actual developer themselves. Sorry, yeah.
Makes sense.
Yeah, or we also have integration with another controller, where actually they use the API itself. So the whole point here is because there is very few greenfield opportunities to deploy this, it's going to be brownfield. And there's going to be certainly a requirement, as much as you want to move to the EVPN, there's going to be a requirement where you're going to have to coexist IPVPN, pseudo wires, LTP signals, and they're going to have to coexist with EVPN, right? Whatever service you want to deploy with the EVPN. And the same thing stands true with the transport model, right? You might want to move to SR, but there's going to some point where you're running LDP, you're going to run LDP potentially, you want to run it with SR at the same time, right? And you could be running SR-TE.
Yeah,
So
Alex, back to your point, again, this is Chris Cummings.
Yes.
Back to your point there about, there's no good flag days really in service provider tech. I do find it interesting, mentioned earlier that VPLS is not currently supported. And for layer 2 VPNs, that is the king today. And so I'd like to hear a little bit more about, what transition mechanisms, kind of what Vince asked earlier is, well, if it's not going to be a big flag day to transition to EVPN, how do you do that if you don't have VPLS for a lot of your layer 2 services? Like what's the risk?
So just to clarify my answer, what I said was VPLS is today, the gateway to EVPN from VPLS is not there today. Sorry, just to be clear.
Could you maybe expand on that a little bit? I'm not sure I quite.
So I think the original question was, how do you migrate from VPLS to EVPN? And the question therefore was, do you have a gateway to allow that to happen? And my answer was, that's something we look to do, but it's not something we have today. So we have VPLS today, we have EVPN layer 2 VPN, but we don't have the gateway to allow you to migrate from one to the other at this point in time.
Okay, so you do have VPLS then?
Yes, correct. Yeah.
Okay, thank you.
So the point being here is that you have to accept that it's going to coexist with different service types and the different transport models that are going to have to coexist. So with that intent, we've built the software stack in a very flexible model whereby the actual service type is completely orthogonal to the transport model. Right. So what I mean by that is that regardless, let's call them the traditional services. So your pseudo wires, your VPLS, your IPVPNs, they could be running over LDP, they can run over RSVP-TE, but they could also run it over SRT. Okay. And the same thing holds true from the newer EVPN type services. So we can run EVPN as a service, but we can also have that running over LDP required, or we can run it over RSVP-TE required, or even run over SRT, right? And the way we do all that is because we built this very flexible tunnel rib framework. So whereby, based on your particular address family and your particular service, you can actually decide which particular tunnel you want to resolve over. So in the tunnel rib framework, you have a colored rib. So the colored rib has SRTEs pass potentially, RSVP pass as well. You can prioritize particularly which one you would prefer, one over the other, if you want to fail over or you don't want to look at all. Then you have the tunnel rib, and there you would have LDP, SR, BGP, and LU, and such like. So I can take each of these different tunnel ribs and can actually align preferences for each of them, and actually then assign them to individual VPN services, right? So the point being here, this allows me, for example, and because we use different label space, and we've seen customers do this, whereby they'd be running the services over LDP. They would then run SR, but they would run SR with no services over it, right? So they would run SR across all their nodes, have SR running, coexisting in the environment, and then at some point or other, once they're comfortable with SR running, they'll get connectivity end to end. They then migrate one of the services over it. And that's possible by realigning the tunnel ribs to allow that particular service to then resolve over SRTE tunnel rather than in an LDP or RSP tunnel, right? Very flexible in that way, right? So the key point here is service type is completely orthogonal to whatever tunnel type you want to resolve over, right? Allowing that migration to happen. So some of the other things that we kind of talked about this as well is that, yes, as we move forward with EVPN, there's going to be a need for gateways. So we have done a lot of work with gateways. I kind of summarize some of the top ones that come top of mind. So we have the ability to stitch together different domains, so LDP domains to SR domains. So whether you want to migrate from one to the other or you want to interconnect them, you get SR mapping server capability on the box. So this allows you to take the mapping server. Basically, we're going to re-advertise LDP prefixes that's in the LDP domain, re-advertise those prefixes with a SID into the SR domain. So the point therefore being is all the PEs in the SR domain can then resolve a tunnel to any PE that resides in the LDP domain, right? and you can therefore have seamless service connectivity across the two domains. Similarly, from a migration or even interconnection perspective, we also have gateway functionality for IPVPN to EVPN services. So the idea being here that I'm interconnecting a layer 3 domain running IPVPN, and I want to connect and provide IP connectivity to PE nodes that are actually running within a separate domain running layer 3 VPNs, so type 5 routes. And what the gateway gives the capability to do is take and learn the IPVPN prefixes and then re-advertise them as EVPN type 5 routes into the EVPN domain. So again, providing the capability to do layer 3 VPN services across the two domains. Right. Any questions there? I know obviously there's other gateways to be addressed here, but kind of just highlighting some of the ones that are top of mind that come up with customers.
I do have a question actually. We've been throwing LDP around a whole bunch as a protocol, but I'm assuming that means LDPv4. Do you support LDPv6?
LDPv4 at this point in time.
Okay. Is there any plan for V6? Has anybody been asking for it?
Don't have an answer to that. Certainly, I've had people asking for it. I don't think it's immediate on the roadmap.
Okay.
So kind of just kind of wrap up here, and then this is something Hisham covered, right? We haven't done all this development work over the past 4 to 5 years, right, in complete isolation, right? So we've been a big active participant in the ENDC Interop Groups event that Hisham talked about earlier on. Now, if you're not aware of the NTC, what the NTC is, what it stands for is the European Advanced Network Test Center. And what they are is an independent, vendor-neutral test facility based in Germany, right? But what's kind of unique about them is like they're actually the only event, there's only event like this that provide interop and vendor interop independence globally. Right, so you have all the major vendors appearing at these events, and it's a yearly event, right? And then in that yearly event, what they do is propose testing new ITF standards, right? And you as a vendor, we as a vendor get also the option as well to actually propose new testing as well based on some of our software roadmap as well, right? But in general, the focus of any use case that you want to be testing is really very much around this next generation solution we're talking about, right? So next generation use cases around EVPN, both within the DC, but also outside the DC. So EVPN, and EVPN with segment routing, EVPN with segment routing in SRTE, right? So as I said, this is kind of our 5th year we've been involved in this, and we've kind of got to the point now where our stack's pretty much rich across all these services, where we've now shown interop capabilities across all the different services I've talked about from an EVPN perspective, right? So VPWS was talked about, VPWS with all active multi-homing, VPWS active standby support. I haven't talked about it, but also we've done VPS flexible cross connect, E3, IRB support with layer 2 VPNs, all active IRB support, all the proxy MAC, and the gateway functionality we talked as well, right? So very rich support now across all those different service types. But I suppose as well, and I think this was talked about earlier on as well, is the fact that when we do all this testing, we're actually doing this testing, the only real vendor that's doing all this testing on merchant silicon that we've talked about, and with a single image, right? So that means regardless of what test we actually do, whether it be even a multicast, an MPLS test, SRTE test, or even a VXLAN test inside the DC, we always use the same image, right? So that really is a big benefit to us to use merchant silicon. Single image really simplifies the whole implementation, right? And gives you a lot of consistency in terms of how the whole thing's configured, troubleshoot it, and automated. So that's kind of me. Is there any questions before I hand it over to Carl and Rich, who's going to talk about these services, but how to actually automate the services?
Yeah, I've got a question for you. What, for the providers that you guys are working on, because we do see Arista getting more and more into service providers these days, whereas, Arista had traditionally been in the data center space. How are you seeing on EVPN as far as, as the move towards EVPN to simplify the control plane? What's the reception been from your service provider customers that have traditionally run MPLS, LDP, VPLS type networks?
Yeah, so I suppose if you look at all the different services that EVPN delivers, right? And you could talk about layer 3 and you could talk about the layer 2 VPNs and everything else. Where we're seeing a sweet spot for it and where we're seeing a lot of interest is actually in the VPWS piece. So replacement of pseudo wires. And where I seems to be something that comes up often is VPWS gives us the multi-home capability, right? That we think is overly complicated in the pseudo. So we certainly see VPWS as the entry point for service providers moving to EVPN. So that's the entry. I'm not saying at that point in time, I'm sure once they get familiar, we have started talking about maybe doing layer 2 VPNs or even IP VPNs. I think that's a little bit further off, but certainly VPWS seems to be the entry point where there is a sweet spot of clear advantage over what point-to-point services are delivering today. I don't know if you would agree with that or.
Yeah, I mean, I think I see that the biggest challenge I see is the Metro Ethernet providers. We had talked about this previously in SP Field Day. Is that for the core equipment makers that are doing the core routing, switching, aggregation, even the edge nodes. When you get down into the Metro Ethernet last mile, and you're talking OLTs and ONTs and fixed wireless, a lot of those vendors are just now getting into routing with MPLS and LDP. So like having the EVPN interop has been a big challenge because I think the service providers see the advantage of simplification and want to run towards it. But with their MEF layer 2 last mile providers not all supporting it and not being able to interoperate, it means we've got to put additional equipment out. So I think everybody's ready for it, but it's tackling that migration.
Yeah, and I suppose it's where that PE sits, right? How far down it sits, right? Because we're certainly seeing a lot of layer 2 rings coming into a centralized PE, and then running the EVPN at that point in time. But to your other point, I think it's quite interesting is, again, when you look at these ENTC events, we're certainly seeing more and more of those sort of, what I wouldn't say, I would more say is layer 2 vendors actually popping up and being involved in EVPN testing, right? So where before they would do a layer 2 metro aggregation that way, they're now looking to do some level of EVPN interop. So it is kind of filtering in to more and more vendors.